Hi, my name is Sunny Patel. Here, me and my mates will explain about the routing using IPv6, and we are starting from the very basics of the IPv6. So, without wasting time, let's just go ahead. So, let's first talk about the IPv4. So, IPv version 4 is 32-bit integer, which is expressed in the decimal notation, as you can see in the example. And there is a three-part: network part, host part, and subnet part. So network part specifies a particular network where these addresses belong to, and the host part is uniquely identifies the machine on that network. And local network that has a massive number of hosts are divided into subnets, and these subnet numbers are appointed to that. So let's just talk about the IPv6. So IP version 6 is very demanding right now, and many companies asked about it in interviews. Many people think that after IPv4, what happened with the IPv5? Like, what happened with the IP version 5? So IP version 5 came, but it was not successful. It was called Internet Stream Protocol. So there is so much versions of IP. It's up, you can't believe it's up to IPv15, but not all of them are used for the addressing. Every different version are used for the different purpose. So even Internet Stream Protocol was in use till few times ago, but it wasn't used for the addressing. And let me give you the clarity that even IPv6 is not the successor of IPv4. Both IPv6 and IPv4 are different from each other, and as IPv6 is not the successor of IPv4, it is not backward compatible. So IPv6 cannot directly communicate with IPv4. For that, we have to use different techniques. So IPv6 is a mode of 128 bits divided into 16-bit segment. It has 34 trillion addresses. Yeah, it has 34 trillion addresses. It is more than enough to give IP addresses to every single thing involved. So IPv6 is mostly used by Asia and African continents because US still has a class A of IPv4, and in Asia and Africa they have given the class C, so they are almost used. So same as IPv4, IPv6 has an unicast and multicast, but instead of broadcast, here we have anycast, which is totally different from the broadcast. So unicast is, it identifies the unique node on a network and usually refers to the single sender or single receiver. Multicast address, it represents the group of IP devices and can only be used as a destination of datagram. So broadcast is also covered in the multicast, and anycast addresses, it is assigned to a set of interfaces that typically belongs to the different nodes. So now let's see difference between IPv4 and IPv6. So IPv4 security permits encryption and to keep up privacy and security, while the IPv6 is more reliable. And this is just, you can stop the video and see the difference. There is not so much more. Now let's talk about the IPv6 unicast routing. Sorry. So it starts forwarding IPv6 packets based on the routing table information. Like unicast is 1-to-1. Like if this PC wants to send something to this PC, then it will be using the unicast. This is the routing configuration of that unicast routing. Now let's see multicast routing. Multicast group is a collection of numerous network nodes. Suppose this host wants to send information to these three hosts, then it can send it using multicast routing. Suppose it wants to send these two hosts, then it can send it using multicast routing, but it sends all of the hosts and it will be broadcast. As I said, broadcast is a part of multicast. Now let's see anycast routing. So if suppose anycast is the same IP address to the different servers, many servers. So if I am in Canada and I search google.com, it will show me the google.ca. If I am in India, then it will show me google.in. So it's just like that. I'm not going too deep in it. So let's talk about the IP routing. So there is two types of routing as IPv4: static routing and dynamic routing. So static routing has three different areas, which is static route for prefix, static default route, and static host route. So what is static route? When a router usually uses the manually configured routing entries rather than information from dynamic routing traffic, it is called static routing. And if a router involves the administrator, learns about the routing information and adds the optimal route to it, then it will be dynamic routing. There is three different areas, types of routing: distant vector, link state, and hybrid. So in dynamic routing there is a thing called administration distance. So this is the table of that distance. Routers utilize this administration distance to rank routes from most desired to least favored. From now on, my friend Mukesh will tell you about the different dynamic routings and static routings. So I'm handing you over to the Mukesh.
We are going to look for IPv6 routing protocols like REAP, EIGRP, OSPF, and how they are used and what are the advantages of using them. So first we are going to talk about REAP, which is a dynamic routing protocol. So REAP stands for Routing Information Protocol, and the key characteristics of REAP are the same as for the IPv4 in both the cases. So the matrix used is hop over here, and also REAP is a distance vector protocol. So now let's see, like there's another big difference in the new version is that with the REAP, the router uses the link local address rather than global address to track the next hop address in its routing table. And REAP uses distance vector algorithm. So that's the algorithm which is being used by the REAP to calculate the best path. And now, so these are the configurations how to enable REAP. And now we are going to talk about EIGRP version 6. So EIGRP version 6 is a function similar to REAP, and it stands for Enhanced Interior Gateway Routing Protocol. So EIGRP is derived from Integrated Gateway Routing Protocol, which is EIGRP. So the metric used over here is bandwidth, delay, load, and reliability. And also EIGRP use diffusing update algorithm to calculate the best path, so the packets are transferred in a shortest path. So also the multicast address are used to transmit hello packets and updates. Its multicast address still 24.0.10 in IPv4, but it's changed to FF002 in IPv6, as A is 10 in hexadecimal notation. So here's a small image about network configuration of EIGRP, and that's how we enable EIGRP in routers. So now I'm going to talk about OSPF. So similar to EIGRP, OSPF stands for Open Shortest Path First, and OSPF is a link state protocol, and the metrics used are bandwidth and delay. So these are the two things which are used, and also OSPF use SPF algorithm to calculate the base path. Now, so version 3 still uses 32 integer based on IPv4 address for both router ID and area ID. So this is like a small image about how we configure router, how we configure OSPF on router. And now we are going to talk about BGP. So let's take it for an example over here. So this is like just a basic introduction to BGP. The protocol known as Broadway protocol is responsible for major network operations and many more things. So let's say when you have a network router that connects to other networks, so it does not know like which is the which network is best and one which to send data to. So there where BGP comes into the picture. BGP takes into consideration all the different peering options a router has and choose the one closest to where the router is. Each potential peer communication the routing information it has, and that gets stored with the routing information base RYB. So BGP can access this information and use it to choose the best peering option. So this is what BGP is all about. And there are two types of BGP, which is internal BGP, also known as interior broad gateway protocol is the name given to the BGP when it's used between two peers within the same autonomous system, and eBGP means when it operates between different autonomous system. So this was, and here's how the BGP is configured. Hi, so as we are done with the routing protocols now, like we talked about RAPE and all those protocols. So now we are going to look how we have implemented those protocol in GNS3. So this is the user interface of GNS3 and with the routers and everything. Just I'll give you a basic walkthrough. Here are the different types of routers and switches and different tools, I would say, different components. And so this was just a small walkthrough, and now the network is over here. It has like different routers over here, and there is AS1 autonomous system 1, 2 and 3. So what we're going to do is we're going to ping from this loop back to this one, and this, like, we are going to check like whether there is a perfect ping test between these three IP addresses or not. So first thing first, we go to router 2 and we just router 2 we ping to this loopback address over here, and let's just see the success rate, and yes, it's working completely fine. Then we'll go to router 5 and we're just going to ping this loopback address. So what we're gonna do is ping 2002 3333, and so it's 1. There you go, it's working completely fine. And now we are going to go on router 8, and just to do a ping test, we're gonna ping router 2 loopback address. So it's 2002. There you go. So there is a complete connectivity between all these three IP addresses. And so now I'm going to just walk through the routing table. So here's the routing table for router 2, and so here's the IP BGP summary of our router 2, and for router 5 here's the routing table, and here are the different types of network which the router has learned via BGP. And here is a different, here is our routing table, and here's the IP BGP summary. And so this was all about the working of the project, and that's how we implemented the BGP summary using those documentation, how to use BGP, IPv6, RIP, and EIGRP and OSPF, and we implemented all those routing protocols at this particular network. So this was everything about the project. Thank you so much for watching.